Hi everyone. Welcome back to channel. Today, we're going to explore the extraordinary life and innovations of Nikola Tesla, a true pioneer in the field of electrical engineering. From his revolutionary inventions to his fascinating personal life, let's dive into the world of Tesla. Nikola Tesla, born July 9-10, 1856, Smiljan, Austrian Empire, now in Croatia, died January 7, 1943. New York, U.S. was a Serbian-American inventor and engineer who discovered and patented the rotating magnetic field, the basis of most alternating current machinery. He also developed the three-phase system of electric power transmission. He immigrated to the United States in 1884 and sold the patent rights to his system of alternating current dynamos, transformers, and motors to George Westinghouse. In 1891, he invented the Tesla coil, an induction coil widely used in radio technology. Tesla was from a family of Serbian origin. His father was an Orthodox priest. His mother was unschooled but highly intelligent. As he matured, he displayed remarkable imagination and creativity as well as a poetic touch. Training for an engineering career, he attended the Technical University at Graz, Austria, and the University of Prague. At Graz, he first saw the Gram dynamo, which operated as a generator and, when reversed, became an electric motor, and he conceived a way to use alternating current to advantage. Later, at Budapest, he visualized the principle of the rotating magnetic field and developed plans for an induction motor that would become his first step toward the successful utilization of alternating current. In 1882, Tesla went to work in Paris for the Continental Edison Company, and while on assignment to Strasbourg in 1883, he constructed, after work hours, his first induction motor. Tesla sailed for America in 1884, arriving in New York with 4 cents in his pocket, a few of his own poems, and calculations for a flying machine. He first found employment with Thomas Edison, but the two inventors were far apart in background and methods, and their separation was inevitable. In May 1888, George Westinghouse, head of the Westinghouse Electric Company in Pittsburgh, bought the patent rights to Tesla's polyphase system of alternating current dynamos, transformers, and motors. The transaction precipitated a titanic power struggle between Edison's direct current systems and the Tesla-Westinghouse alternating current approach, which eventually won out. Tesla soon established his own laboratory, where his inventive mind could be given free rein. He experimented with shadowgraphs similar to those that later were to be used by Wilhelm Röntgen when he discovered X-rays in 1895. Tesla's countless experiments included work on a carbon button lamp, on the power of electrical resonance, and on various types of lighting. In order to allay fears of alternating currents, Tesla gave exhibitions in his laboratory in which he lit lamps by allowing electricity to flow through his body. He was often invited to lecture at home and abroad. The Tesla coil, which he invented in 1891, is widely used today in radio and television sets and other electronic equipment. That year also marked the date of Tesla's U.S. citizenship. Westinghouse used Tesla's alternating current system to light the world's Columbian Exposition at Chicago in 1893. This success was a factor in their winning the contract to install the first power machinery at Niagara Falls, which bore Tesla's name and patent numbers. The project carried power to Buffalo by 1896. In 1898, Tesla announced his invention of a teleautomatic boat guided by remote control. When skepticism was voiced, Tesla proved his claims for it before a crowd in Madison Square Garden. In Colorado Springs, Colorado, where he stayed from May 1899 until early 1900, Tesla made what he regarded as his most important discovery, terrestrial stationary waves. By this discovery, he proved that Earth could be used as a conductor and made to resonate at a certain electrical frequency. He also lit 200 lamps without wires from a distance of 40 kilometers, 25 miles, and created man-made lightning, producing flashes measuring 41 meters, 135 feet. At one time, he was certain he had received signals from another planet in his Colorado laboratory, a claim that was met with derision in some scientific journals. Returning to New York in 1900, Tesla began construction on Long Island of a wireless world broadcasting tower with a $150,000 capital from the American financier J. Pierpont Morgan. Tesla claimed he secured the loan by assigning 51% of his patent rights of telephony and telegraphy to Morgan. He expected to provide worldwide communication and to furnish facilities for sending pictures, messages, weather warnings, and stock reports. The project was abandoned because of a financial panic, labor troubles, and Morgan's withdrawal of support. It was Tesla's greatest defeat. DC power transmission was soon supplanted by AC systems that transmit power at very high voltages and correspondingly low current, and easily use transformers to change the voltage. However, current DC systems can easily change voltages. Current AC systems transmit power from generators at hundreds of thousands of volts and use transformers to lower the voltage to 220 volts, as in much of the world, or 120 volts, as in North America, for individual customers. Electrical phenomena attracted the attention of European thinkers as early as the 17th century. The most noteworthy pioneers include Ludwig Wilhelm Gilbert and Georg Simon Ohm of Germany, Hans Christian Ørsted of Denmark, André-Marie Ampère of France, Alessandro Volta of Italy, Joseph Henry of the United States, and Michael Faraday of England. Electrical engineering may be said to have emerged as a discipline in 1864 when the Scottish physicist James Clerk Maxwell summarized the basic laws of electricity in mathematical form and showed that radiation of electromagnetic energy travels through space at the speed of light. Thus, light itself was shown to be an electromagnetic wave, and Maxwell predicted that such waves could be artificially produced. In 1887, the German physicist Heinrich Hertz fulfilled Maxwell's prediction by experimentally producing radio waves. The first practical application of electricity was the telegraph, invented by Samuel F.B. Morse in 1837. The need for electrical engineers was not felt until some 40 years later, upon the invention of the telephone, 1876, by Alexander Graham Bell, and of the incandescent lamp, 1878, by Thomas A. Edison. These devices and Edison's first central generating plant, in New York City, 1882, created a large demand for people trained. In 2003, American entrepreneurs Martin Eberhard and Mark Tarpenning founded Tesla Inc., the manufacturer of electric automobiles, solar panels, and batteries, in honor of the inventor. Tesla Inc. quickly became one of the most recognizable car brands in the world. Alternating current, flow of electric charge that periodically reverses. It starts, say, from zero, grows to a maximum, decreases to zero, reverses, reaches a maximum in the opposite direction, returns again to the original value, and repeats this cycle indefinitely. The interval of time between the attainment of a definite value on two successive cycles is called the period. The number of cycles or periods per second is the frequency, and the maximum value in either direction is the amplitude of the alternating current. Low frequencies, such as 50 and 60 cycles per second, hertz, are used for domestic and commercial power, but alternating currents of frequencies around 100,000 cycles per second, 100 megahertz, are used in television, and those of several thousand megahertz in radar or microwave communication. Cellular telephones operate at frequencies of about 1,000 megahertz, 1 gigahertz. For decades, alternating current AC had the distinct advantage over direct current DC. A steady flow of electric charge in one direction, of being able to transmit power over large distances without great loss of energy to resistance. The power transmitted is equal to the current times the voltage. However, the power lost is equal to the resistance times the square of the current. Changing voltages was very difficult with the first DC electric power grids in the late 19th century. Because of the power loss, these grids used low voltages to maintain high current and thus could only transmit usable power over short distances. The discovery of thermionic emission, or the Edison effect, a flow of current through the vacuum of one of his lamps, was the first observation of current in space. Hendrik Antoon Lorentz of the Netherlands postulated the electron theory of electrical charge in 1892, and in 1897 J.J. Thomson of England showed that thermionic emission was indeed caused by negatively charged particles, electrons. This led to the work of Guglielmo Marconi of Italy, Lee De Forest of the United States, and many others, which laid the foundations of radio engineering. In 1930, the term electronics was introduced to embrace radio and the industrial applications of electron tubes. Since 1947, when the transistor was invented by John Bardeen, Walter H. Brattain, and William B. Shockley, electronics engineering has been dominated by the applications of such solid-state electronic devices as the transistor, the semiconductor diode, and the integrated circuit. Consulting the rapid proliferation of new discoveries, products, and markets in the electrical and electronics industries has made it difficult for workers in the field to maintain the range of skills required to manage their activities. Consulting engineers, specializing in new fields, are employed to study and recommend courses of action. The educational background required for these functions tends to be highest in basic and applied research. In most major laboratories, a doctorate in science or engineering is required to fill leadership roles. Most positions in design, product development, and supervision of manufacture and quality control require a master's degree. In the high technology industries typical of modern electronics, an engineering background at not less than the bachelor's level is required. To assess competitive factors in sales engineering to guide marketing strategy, current is usually denoted by the symbol I. Ohm's law relates the current flowing through a conductor to the voltage V and resistance R. That is, V. An alternative statement of Ohm's law is I Ninchen VR. Current in gases and liquids generally consists of a flow of positive ions in one direction together with a flow of negative ions in the opposite direction. To treat the overall effect of the current, its direction is usually taken to be that of the positive charge carrier. A current of negative charge moving in the opposite direction is equivalent to a positive charge of the same magnitude moving in the conventional direction and must be included as a contribution to the total current. Current in semiconductors consists of the motion of holes in the conventional direction and electrons in the opposite direction. Currents of many other kinds exist, such as beams of protons, positrons, or charged pions and muons in particle accelerators. Electric current generates an accompanying magnetic field, as in electromagnets. When an electric current flows in an external magnetic field, it experiences a magnetic force, as in electric motors. The heat loss, or energy dissipated, by electric current in a conductor is proportional to the square of the current. A common unit of electric current is the ampere, which is defined as a flow of 1 coulomb of charge per second, or 2 × 1018 electrons per second. The centimeter gram second units of current is the electrostatic unit of charge, ESU, per second. 1 ampere equals 3 × 109 ESU per second. Commercial power lines make available about 100 amps to a typical home. A 60-watt light bulb pulls about 0.5 amp of current and a one-room air conditioner about 15 amps. For more on electric current, see electricity, direct electric current and electricity, alternating electric currents. Thanks for watching.